Our lesson today is to be able to solve equations with variables on both sides. The key idea here is that to solve equations with variables on both sides, we want to collect the variable terms on one side and the constant terms on the other side. Okay, here's our first example. You'll notice that this equation looks very different from all of the equations we've done in the past because this equation has variables on both sides of the equation. I have a negative 2x on the left side of the equal sign, and I have a negative 7x on the right side of the equal sign. So the goal is to find the value that's going to make this equation true, the value for x that will make the equation true. I always like to teach my students that when you have an equation with variables on both sides of the equation, it's best to remove the variable with the smaller coefficient. And the reason for that is you're going to make your computations a bit easier if you start by removing the variable with the smaller coefficient. So let's look at our coefficients. The coefficients are the numbers that are multiplying the variables here. I have negative 2 as a coefficient on the left side of the equation, and on the right side of the equation I have negative 7. Negative 7 is less than negative 2. So my first step here to remove the variable with the smaller coefficient is going to be to add 7x to both sides of this equation. Now on the left side of the equation we have 15 is going to be and then when we add 7x to 2x, that's going to give us 5x. So we have 15 plus 5x is going to be equal to negative 7x, and positive 7x is 0. Now in order to get the variable by itself, we'd have to subtract 15 next from both sides of the equation. On the left side of the equation that's going to be 0. I'm left with 5x is going to be equal to negative 15. My last step is to divide both sides of this equation by 5, and then we wind up with x is equal to negative 3. I check my equation to see if that value for x is going to make the equation true. So let's substitute negative 3 for x in both situations. 2 times negative 3 is going to be negative 6. 15 minus negative 6, when we add its opposite, is going to be 15 plus 6 is 21. Is 21 on the left side of the equation the same as negative 7 times negative 3? Yes, it is. So I know the value for x is negative 3 because it's going to make that equation a true statement. Okay, let's try another type of problem. Here we have the distributive property on the left side of the equation, and we have the distributive property on the right side of the equation. So when we have that situation, we want to first use the distributive property. Let's distribute this negative 2 times this difference. Negative 2 times x is going to be negative 2x. Negative 2 times negative 5, a negative times a negative is positive, so I just write that as plus 10. That's going to be equal to 6 times 2, which is 12, minus 6 times 1/2 x. 6 times 1/2 is going to be 3, so 6 times 1/2 x is going to be 3x. We see that situation described in the last problem where we have variables on both sides of the equation. I have a negative 3x on the right side of the equation, negative 2x on the left side of the equation. Let's remove the variable with the smaller coefficient. Negative 3 is smaller than negative 2. So I'm going to add 3x to both sides of that equation to remove the variable with the smaller coefficient. On the right side of the equation, that's going to be 0. Negative 2x plus 3x is going to be 1x. I still have that plus 10, and that's going to be equal to 12. I have a nice simple one-step equation here where I'm going to subtract 10 from both sides of that equation. On the left side of the equation, they're opposite, so that's going to become 0, and we're left with x is going to be equal to 2. Alright, let's check that solution, see if it makes the equation true. 2 minus 5 is going to be negative 3. Negative 2 times negative 3, I get positive 6 on the left side of the equation. Let's see if we get positive 6 over here. 1/2 times 2, 1/2 times 2 is 1, 2 minus 1 is 1, 6 times the 1 is going to be 6. So I get 6 on the left side of the equation, I get 6 on the right side of the equation, so I know that value for x is the solution because it makes the equation true. Okay, let's try these examples here. Example number 1, I have variables on both sides of the equation. Right, on the left side I see a negative 3x, on the right side I see a 2x. So I want to remove the variable with the smaller coefficient. Negative 3, a negative, it will always be smaller than a positive, so I want to remove the negative 3x. I add its opposite, so that's going to be plus 3x, and that's going to make that 0. But if we add 3x on one side of the equation, we have to add 3x to the other side of the equation. I'm left with 0 is equal to 5x plus 19. In order to get x by itself, we'd have to subtract 19 from both sides of the equation. We wind up with negative 19 is going to be equal to 5 times x. And when we divide both sides of the equation by 5, divide by 5, they cancel. We wind up with x is going to be equal to, what's that, negative 4, no, 5 times 3 is 15, 5 times 4 is 20, so that's, leave it as negative 19 over 5. Right, you could write it as a mixed number, you could write it as a decimal, but negative 19 over 5, right, that's going to be fine. Let's try our next problem. I see I have variables on both sides of the equation. I want to remove the variable with the smaller coefficient. 2.5 is smaller than 4.5. So let's remove the 2.5 y from the left side of the equation and remove 2.5y from the right side of the equation. On the left side of the equation, that becomes 0. We're left with 6 is going to be equal to, well, 4.5y, take away 2.5y, that's going to be 2y. And then we have minus 1. In order to get the variable by itself, we'd have to add 1 to both sides of the equation. That becomes 0. 6 plus 1 is 7. So I'm left with 7 is equal to 2 times y. To solve for y, we're going to have to divide both sides of that equation by 7. They cancel, and we wind up with, scroll up a little bit, we wind up with 7 halves is equal to y. Is equal to y. Alright, let's look at this next example. I see the distributive property, so I want to distribute that 6 to each of the terms in the parentheses. 6 times 4 is 24, minus 6 times z, we'd write that as 6z. That's going to be equal to 2z. After the distributive property, we see we have variables on both sides of the equation. I want to remove the variable with the smaller coefficient. Negative 6 is smaller than positive 2. So I'm going to add 6z to both sides of that equation. That becomes 0. We're left with 24 is going to be equal to 8 times z. I want to divide both sides of the equation by 8. On the right side they cancel, so we're left with z is going to be equal to 3. Well, 3 is easy enough to check. Right, so let's check that. Let's rewrite that. 3 is equal to z. Right, let's check that. 4 times 3 is 1. 6 times 1 is 6. 2 times 3 is 6. I do get 6 on the left side of the equation. I get 6 on the right side of the equation. So I know that 3 is the solution for this equation. Now, when we're dealing with equations with variables on both sides, we can have several different types of solutions. We can have an equation where there are no solutions. We can have an equation where there's a one solution, and an equation where we have an infinite number of solutions. The equation with no solutions we also call the null set. An equation with infinite solutions we call an identity. The equations we've done so far during the lesson have had one solution, right? The one value that's going to make the equation true. Here, with our next couple of examples, it's going to be a little bit different. We may have more than one solution, or we may have no solution. Okay, so let's take a look at this next example. All right, it says this is going to be an equation with no solution. So let's see what that looks like. I see a negative 4x on the left side of the equation. I see a negative 4x on the right side of the equation. Notice that the variables have the same coefficient, so it doesn't matter which one we start with it to remove. So I'm going to add 4x on the right side of the equation. I'm going to add 4x on the left side of the equation. Right? They both become zeros. Well, what's left? Well, on the left side of the equation, we have a 3. On the right side of the equation, we have negative 7. 3 can never be equal to negative 7, right? They're not equal. So this would be an example of a null set of solutions, right? Null set, or we would write no solutions. No solutions. And we're going to recognize equations with no solutions. This is the characteristic that you're going to see. The coefficients will be removed, so you'll be left with no variable. You'll be left with an equation where one thing is not equal to another. All right? Well, if that's no solutions, what will a solution look like where we have infinite solutions? Okay, let's see. Well, I'm going to recopy the left side of the equation. 6x plus 4 is equal to, now on the right side of the equation, we have to distribute this 4. 4 times 3 is 12, divided by 2. It's going to be 6x plus 4 times 1 is 4. Notice what happens when you have infinite solutions, right? You have variables on both sides of the equation that have the same coefficient. So when we subtract 6x from both sides of the equation, right, that's going to be 0. That's going to be 0. Well, what's left? On the left side of the equation, we have a 4. On the right side of the equation, we have a 4. We have a situation where 4 is equal to 4. Well, what does that mean? Well, that means then for this equation, no matter what value we replace x with, that equation is true. There are an infinite number of solutions to that equation. And you're going to learn a little bit later, maybe this year, but also in Algebra 1, that when we graph these equations, right, this first example of no solutions, right, they're going to be parallel lines, right? They never intersect, no solutions, right? Whereas here, infinite solutions, when we graph them, you're going to have overlapping lines. So, you'll be able to see these characteristics graphically as well. Well, let's try these next couple of examples. I see the distributive property here, so let's do that. It's going to give us 18 minus 3 times 4 is 12x is equal to negative 2 times 6x is negative 12x, negative 2 times negative 9, positive 18. Right? If I try to remove one of my variables, right, I add 12x to both sides of the equation. They cancel. They cancel. I'm left with 18 on the left side of the equation, left with 18 on the right side of the equation. Right? And that's an example of infinite solutions. Right? Because I have the same constant left on both sides of the equation. Right? So those are infinite solutions. Okay. Our next one. Distribute the 2. 2 times 3x is 6x. 2 times 5 is 10. Distribute here. We have 5 times 2x is 10x. 5 times 4 is 20. Then we have minus 4x. On the right side of this equation, I can combine like terms. 10x minus 4x. I get 6x minus 20 on the right side of the equation. On the left side of the equation, we have 6x minus 10. When I remove my variable, right, we subtract 6x from both sides of the equation. Right, they both become zeros. So I'm left with negative 10 is equal to 20. Right, and that can never happen. Negative 10 can never be equal to 20. So that's an example of no solutions. Alright, okay, let's see what else we got here. Okay, we'll try a few more, and I think that will be it, right? So yeah, let's try these 4 examples, see what we come up with. Right, problem number 4, I'll copy here. Problem 4, we have 2x plus 1 equals 2x minus 1. All right. If we subtract 2x from both sides of that equation, right, they zero out on both sides of the equation. We're left with 1 is equal to negative 1. Right? Can 1 ever be equal to negative 1? Right? The answer is no. Right? So there are no solutions. Right? So, or we call that the null set. No solutions. All right. Problem 5. Let's do that here. Problem 5, we have 1/2 6 times t minus 4, close parentheses, equals 3 times t minus 2. I use my distributive property over here. 1/2 of 6 is 3, so we have 3t minus 1/2 of 4 is 2. That's going to be same as the 3t minus 2 over here. And it's at this stage most students are going to recognize that this is an example of infinite solutions, because I have the same exact thing on the right side of the equation as I do on the left side of the equation. I have the same expression, 3t minus 2, on the left side as I do on the right, 3t minus 2. However, if we go ahead and remove those variables, right, that's going to be 0. We're left with negative 2 on the left side of the equation, right? We're left with negative 2 on the right side of the equation, and that's an example of infinite solutions, right? Infinite solutions. Okay? All right, let's try 6 and 7. Doing it green here, problem 6. All right, we have 1/2 times 2b, or not to be, plus 9 is equal to 2/3 times b plus 9 over 2. All right, what do we have here? Distributive property on the left side equation. 1/2 of 2 is 1, so that's 1b plus 9 over 2 is equal to, over here, 2/3 b. 2/3 times b is 2/3 b plus, what's this gonna be? This is numerator times numerator is 18. Denominator times denominator is 6. 18 over 6. All right, we extend that a little bit. I have 2/3. I have b. I want to remove the variable with the smaller coefficient. 2/3 is smaller than 1, so I'm going to subtract 2/3 b from both sides of that equation. Oops. Right, 2/3 b. What is 1? Take away 2/3, we get 1/3 b plus 9 over 2 is going to be equal to, right, because that's 0, 18 over 6. Well, if I look at this equation, a lot of different ways we can do this. I want to multiply everything by the least common multiple of 3, 2, and 6. It's going to be 6. So I'm multiplying both sides of the equation by 6. But because there are two terms on the left side of the equation, I have to multiply each of those two terms by that 6. 6 times 1/3, 6 times 1 is 6, divided by 3 is 2. So that's 2b plus 6 divided by 2 is 3, times 9 is 27. That's going to be equal to 6 here, cancel 6 here, so that's 18. Do all that work, nice simple two-step equation here. Subtract 27 from both sides of the equation. That becomes 0. We're left with 2b is going to be equal to 18, take away 27, what's that, negative 9. Divide by 2, divide by 2, and we wind up with b is going to be equal to negative 9 over 2. b equals negative 9 over 2. Alright, let's do our last one. And our last one says, let's see, question 7. Alright, I want to recopy that. So let's go here. Right, that's going to be problem 7. 6 times 5 minus 2v is equal to negative 4 times parentheses 3v plus 1. On the left side of the equation, I see the distributive property, so we'll do that first. 6 times 5 is 30. 6 times 2 is 12, so that's minus 12b, is equal to negative 4 times 3 is negative 12b. Negative 4 times positive 1, negative 4. I see the same variables here, so I'm going to add 12v on both sides of this equation. All right, add 12v. That's going to be 0 here. That's also going to be 0 here. Well, what's left? We have 30 on the left side of the equation is going to be equal to negative 4. 30 can never be equal to negative 4, so they're not equal. So that's an example of the no set or no solutions. Alright, so we've done a bunch of problems here. A couple of key things to take away. First, when you have variables or equations where you have variables on both sides, you can have one of three situations. You can have one solution, like we do in example 6. We can have infinite solutions, like we do in example 5, or we can have no solutions, like we do in examples 4 and 7. Second thing to take away, when we have equations with variables on both sides, we want to start off by removing the variable with the smaller coefficient. We do that to make our calculations a bit easier. We're trying to put the variable term on one side of the equation, the constant on the other side of the equation. Right, I hope that was helpful, and we will see you soon.